really, I think it's a combination of a lot of aspects in my childhood and education that led me to the science world. I think initially the main interest I had at some point in my childhood was to go to the university, because I could see my oldest sister going to the university. We have quite some difference of age, and I understood that at a rather adult age, one has a possibility to, in a way, kind of remain in a type of school and also continue teaching and do research by asking a lot of questions. And I was more interested in this approach, which for sure is very much associated to science. So I think this is maybe the main point. And then after, the interest to biology came later. Maybe again a combination of experiences. Certainly a teacher of biology when I was 11, 12 years old must have raised my interest in biology to a certain extent, because when I joined the Pasteur Institute as a master's student, and I told my mother, okay, I chose a lab at the Pasteur Institute. She told me, when you were 12 years old, you came back, around 12 years old, you came back from school and you said, one day I will work at the Pasteur Institute. But she never reminded me this. So I think, yeah. And there are some, obviously, different types of experiences that must have, after, conducted me to the world of science, and specifically biology. I don't know actually why I chose biology at some point. Again, it must have been a gut feeling. I was hesitating between mathematics and biology. I decided to go to biology. I think maybe because I was interested always in asking a lot of questions, or let's say I had a lot of questions with regard to us as human beings, confronted to diseases, confronted to not only physical diseases, but also mental diseases. So I've been always interested in also in everything related to psychology, psychiatry. And then when you start to understand the biological world, and specifically when you start to understand the microbial world, you also understand that the microbes work quite much as, you find a lot of sociological aspects in the microbial world that are quite similar to our world, with, a lot of aspects that are very similar. But for sure, there are microbes. They do not have a brain. They react differently. But this idea that they live in a society, they have to adapt. A lot of aspects that are quite much also related. And so I thought that in biology one can nevertheless ask more questions, that it's maybe more fruitful with regard to the idea of understanding the world and understanding oneself. And it's also an experimental world. And I was also interested in the fact that there is an intellectual aspect, but there is a methodological and experimental aspect, and I was also interested in this. So I think the combination of everything led me more to biology. Yeah, obviously a biology teacher, certainly, that I remember from when I was 11, 12 years old. I also remember actually a teacher in physics, 2-3 years later. And this teacher was important because from this teacher I remembered the experimental work at the bench that was also put forward in a kind of enjoyable way, and also working with the other students. So understanding that this was not only doing experiments on its own, but also communicating with the others in the room to make the experiment work, and that it was also an enjoyable and fun experience. It was a little bit out of listening to a teacher stating dogmas and facts, and I think this was maybe also part of my interest in the experimental science. So actually, doing research is is a lot about dealing with frustrations and failures. It's really part of being a researcher. It's actually also part of the success of a researcher. I believe, at least in my case, I would not have been successful if I had not encountered a number of failures and frustrations. And actually, the CRISPR project in my lab really started by certainly dealing with frustrations of having discovered an RNA molecule that is essential for the CRISPR-Cas9 system that is called tracer RNA. And then when we identified this RNA molecule and we thought of a certain function of this RNA molecule and not being able to make a sense of this function and mechanism. So it was by, after 2-3 years of frustration, specifically from students who were doing the experiments, and then the idea to link this molecule to CRISPR, where again, I had difficulties to motivate a student who were working on this molecule to pursue and shift direction. So she didn't want to do it. And after a year, another student said, okay, I'm going to do the experiment you have to do because you really insist a lot. And actually, it's also being ready to take, new ways and think differently, out of the box. And in the case for CRISPR, was thinking out of the box for the tracer RNA molecule and also thinking out of the box for CRISPR, mentioning that CRISPR research, as much as Nobel has awarded the research on CRISPR-Cas9, it also involved a lot of pioneers, excellent researchers who started to work on CRISPR that was unknown, started to understand what the CRISPR system was in bacteria, that it was an immune system against viruses and other mobile genetic elements, starting to understand certain mechanisms of CRISPR. And this is, all this knowledge that allowed me as well to think, oh, it seems like I deal with another type of CRISPR-Cas mechanism must be different. So it's a lot of methodology, and it's a lot of failure. It's part of being a researcher. Experiments sometimes and very often fail technically, so we have to troubleshoot. It's a lot of troubleshooting. And then in the hypothesis or in the strategy and the methodology of what to do first, what to look at, it's a process. So it's always A, B, C, and then plan A, plan B, plan C, plan A1. For CRISPR, this was maybe the most strategic and effective plans that I elaborated. And so it was a lot of, strategy, plan A, plan B, plan C, and A1, A2, and, going forward in this direction. Not being afraid of failures, otherwise one cannot be a researcher. As a researcher, but I guess it's maybe for everyone, even who's not a researcher, one deals with a lot of barriers in life, right? Specifically during a career path. Specifically more being a woman, I guess I try to not really look too much into the fact that I was a woman, but rather look into the fact that I am a scientist, and as a scientist, you have to encounter enough barriers already. Actually, as a matter of fact, I'm a woman in science, but I've also been an international scientist. So this also, let's say, triggers maybe more barriers because one has to deal with, another type of, culture and another type of environment that can be very fruitful, but can also lead to some difficulties or some, let's say, more time for adaptation. There are lots of women in science nowadays. The topic has evolved quite dramatically the past, 30 years. We find more and more women studying science, more and more women who let's say 10 years ago, 15 years ago, decided to pursue, a career in science. The system has also facilitated more the access and, a change of culture that would understand that it's very interesting and it's very important to maintain diversity also within the faculty among the the professors and the group leaders, because this is an enrichment. Maybe it's not enough. The world is still quite masculine. So, and the decisions are maybe still taken a lot by researchers who are, men. I hope it's going to evolve. I'm a bit concerned with the fact that it has evolved, and for the past few years we tend to see more young female scientists having, let's say, not, I don't know if it's the courage, but let's say deciding to not pursue with a group leader position. So I hope that this is just a bad timing, and that there will be more in the future. But this is, I guess, what we observed all over the world on other topics, and I hope that this will raise. But as a researcher, one has enough buyers, and also to mention very importantly, and I think this is good, you see a change also of culture in also the junior leaders who are men, because this is now a new generation who wants to integrate more time for the family, and this is not any longer a question for female scientists, but also for male scientists who also are now confronted to the issues that for sure research requires a lot of time, a lot of commitment, and that one has to have it compatible with a family life. So it's interesting to see that all the problems that women had, it also become also problems of young male, group leaders, which I think is good in a way, because it shows an evolution of our society in the right way. Yeah, I think a message for the young female researcher will be to not think that certain topics in life are just only for men. I think they have access in nowadays to different types of science, and I think the infrastructure has facilitated a lot the integration of female scientists and international scientists. So I think they should go for it, not be concerned by fears or a lack of self-confidence. Actually, I have worked also a lot with men, and often I was surprised to know to which extent they were actually like female scientists, and they deal with the same issues. They just don't maybe express them the same way. But they deal also with frustrations. They deal also with sometimes a bit of a lack of self-confidence. They may tend to maybe express it differently, or they are for sure raised in knowing that they have to show their self-confidence, and the female, they are more prone to show a certain lack of self-confidence. But I think at the end of the day, I kind of understood that we are all sitting in the same boat. It's just the way to express that may be different, and I think it's important to encourage the young scientists to understand, and the young females to say, no, we are all the same, and they have to get ways. And I think nowadays they can be helped also to be coached and to learn to deal with maybe certain traits that need to be improved for being a scientist. I think nowadays you have also the possibility to have mentors, coaches who can accompany, and make the journey a little bit easier, and also to make the journey in the sense that to accompany the young scientists to say, yes, it's nice, a path in science, and not focus really on the career, but just, to be a scientist and evolve to then after become a group leader, not because it's a career, but because then after, I guess it's also our role to then convey the science to the next generation and deal with a group. So it's not a question of career, it's a question maybe of a natural path that is, then you grow and you teach the science to other people, and you convey the science to the younger generation, and it's Yeah, and it's very nice. There are issues like for everything, but it's very nice. Yeah, so the general advice I give is always to listen to oneself. I think it's important to listen to oneself and follow the gut feeling, follow the intuition. And in research, what is really important is to let's say, to follow what one likes to do. So sometimes, for sure, I was also confronted sometimes that, I liked different topics, so it was difficult to choose. But I think what helps a lot is just to enjoy what, the science, and see, to see what the science can really bring. So focus on this, and really try to trigger in oneself the sense of curiosity, of what we like to do, and the joy of the science. And this, it's important because it allows to deal with the rest. And this is what I try to encourage. I think science is also, it's also nice, it's enjoyable, so they have to learn to all these aspects, to see this aspect and see that the rest, these are little steps that may not work perfectly, but that at the end of the day make the beauty of this work that is very typical. We are very, how do you say, privileged to be able to ask questions and work on what we like to work. So this, it's, I think, a very privileged situation. So to become a scientist, you need a number of qualities. You need to be patient, but yet be impatient. So it's a combination of both. You need to be curious, I think, persistent. You need to analyze very well. I mean, be methodologic. I think it's important. Be logic, have the right intuition. Be curious. Know how to deal with frustrations. And I have to say that in biology, it's also work. I mean, I would say it's a little bit mathematic. The more experience one is doing, the more results you produce, and the more chance you have to let's say, to maybe understand something unique. So, and it's a lot of time with oneself, to give the time to really think properly, read, so acquire the knowledge, but also enough time to take distance from the knowledge, to be able to think out of the box and be creative. So I think what helps as well is to have some activities outside, the work, but still it's a lot of work. So I think it's not really something from 9 to 5, because the typical scientist will work a lot, but the typical scientist is not going to think at a specific time. Will think at different times. But it's really important also to bring some artistic activities, or I would always mention sportive activities, because the brain works a lot in the background. So one has to a little bit, have some activities that uses the brain in a different way. But in biology, it's a lot of work. One has to be very committed. Criticizing, it's very important in research. And it's very important that you ask this question, because a key also for success for a researcher is to know how to accept criticism. We are constantly judged, and our work is constantly criticized by our colleagues and peers, and we have to deal with it. And a good way is to first, self-criticizing oneself. Like this, we can deal more with the critics of the others. But it's like this that we go forward with our new dogmas and new findings. Yes, because I was studying piano and ballet dance. So ballet dance for a very long time, until my nearly 30s. Piano, I stopped at 14, 15 years old. I started at 6, 7. I think this was very important for me, because I think I find in those artistic activities, quite much what we need as a scientist. It's a lot of repetition, a lot of methodology, a lot of also, how do you say, one has to be focused and concentrated, and also hard on oneself, right? I mean, when you do ballet dance, it's not always the easiest, I think, physical activity. So I think it's very helpful to also deal with frustrations, and you have creativity and also emotions in there, which I think you have also in science. I always had an interest in, early on in the literature, and then now it's been long years I don't have really time to read the way I would like to read. So it's a little bit problematic with the life I'm having, or I read articles or news, but unfortunately less time to read books. So I hope in the future I can let's say deal with this frustration. But otherwise I've always been interested in culture and arts thanks to my parents. And I think the ballet dance, it's also quite physical, as a matter of fact. And I realized recently that actually this was important for me. I had missed out on having a regular physical activity, so I'm doing a lot of sport. And I think for me it's essential. I belong to the people who are more effective while moving and exercising. There are some people, they need to be static. Me, I need to move a lot. And so I think I think people are different, but you have a lot of scientists who are, actually I know a lot of scientists who are very active physically. It's very interesting, because I believe that you have different types of scientists, those who really need to move a lot to be creative and go in a productive way in their life as a scientist. What is very interesting in the CRISPR topic is that a lot of scientists from different fields actually got interested into CRISPR. So you had the pure bacteriologists, those who were working on viruses of bacteria, those working on enzymes, those working like me on small RNA molecules, and also in the past phages, structural biologists like Jennifer Doudna. So a lot of people came together to try to join forces to understand what CRISPR-Cas was about. And when we started to work on CRISPR-Cas9, we had a first collaboration with an RNA group working on bacteria, the group of Jörg Vogel with Cynthia Sharma, and then a second collaboration with Jennifer Doudna. It was at the time where the project needed more structural biology aspect. And so then after, as typical it is for collaboration, you have to meet the collaborators somewhere. So we met at a conference, and I approached her to ask her whether she was interested to decipher the structure of the protein CRISPR-Cas9, because she was already working on other types of CRISPR-Cas systems. And then, it's a kind of, I guess, for every collaboration, as it seems, as long as we are not forced to collaborate, which in general, we may be forced to collaborate thanks to a funding, but we find our collaborators, and in general, we try to find collaborators we think we will be able to work with, because we don't know when we meet the person. And as a matter of fact, here it was a collaboration that was working well, also because the younger scientists effectively doing the experiments were also, enjoying to work together at distance. At the time, we were using Skype. This is important, You have the people doing the experiments in a collaboration. It does not work if only the principal investigators think that they can work together. Effectively, the scientists doing the experimental work has also to come together, and this was the case. And even though the collaboration was very short, it was intense, but then after, because of the impact of the work, we very, very soon, actually, after we published the collaborative work, we found ourselves participating in a lot of events where we receive, awards or other type of events where we will convey, the science that we had done. And so this meant that we had a lot of opportunities to meet. And so over the past 10 years, we met extremely often in different types of events. And this was maybe quite peculiar because of the real impact of the technology extremely fast. So we were finding ourselves in a lot of of events. So that was a very unique, I think, maybe story. I mean, me, I was trained as a biochemist, geneticist, microbiologist, but we have the same way of approaching very precisely the research. And I think this we shared in common. Also in common the fact that, you know, when you collaborate, you have for sure different types of scientists, and us, we are really much, maybe because of the type of research that we are doing, you know, it was very important for us to approach the research in a very precise way, and to make sure that, you know, the research will be done and, you know, really reproducible, etc. So this was also important to work with a scientist who has the same view. And so this, and I have a lot of respect for her as a scientist. It is interesting, as a matter of fact, that the CRISPR-Cas technology has had an impact on humankind actually quite fast. So it's a technology that is explained as molecular scissors, and that has the ability to edit the genes and the expression of genes in multiple cells and organisms in a very precise manner, in an unprecedented way, in the sense that the tool allows to do precise genetics, but the tool can be programmed and designed in a simpler way compared to the tools that were available prior to CRISPR-Cas9. And it has had very, very fast, large implications in life sciences globally, in biotechnology, in medicine, and in research and development. And it has an impact on humankind in the sense that beyond the great, how do you say, applicability of the technology as a direct medicine, because it is now really being developed for curing certain types of diseases, and we see the first cures occurring to treat human blood genetic disorders. It has also a great impact in understanding the mechanisms of life, which for sure contribute to also lead to, you know, the development of biotechnologies in general, with also, you know, all the technologies that are used to produce new types of biofuels, or also, how do you say, request a large number of technologies, including genetic technologies, for, you know, genetic engineering and systems biology and so on and so forth. There are also great applications in, so beyond the research and development in the clinical sector, in the biotechnology sector, there are also great implications in plant biology, in the production of plant crops, specifically in the world of global warming and global climate changes, the necessity to be able to engineer crops that can sustain the changes that are meant to be encountered in the very near future and even long-term future. So, you know, we all, I guess, in the life of today, we benefit so much of a great well-being thanks to a number of, you know, technologies, also, you know, improvement of food and you know, and medicine and health, and CRISPR-Cas has a great impact in this kind. That's why it has a really, it impacts, let's say, humankind. Yes, so very, very fast, I met certainly scientists who were extremely pleased to have this technology that would allow them to do precise genetics in their cells and organisms of interest, which was not possible prior to CRISPR-Cas9. Not to such, let's say, democratic fashion and you know, easy way to design, and also at low costs. And this, I saw it very fast. And you know, what is very interesting is that I still for sure meet scientists. So now after 10 years, I meet scientists who were not scientists 10 years ago, and who thank me for having, you know, given them the possibility to start science and to start projects, asking questions they would not have been able to ask prior to 10 years ago. I also receive, thanks from scientists who definitely can also answer questions they could not answer, and that also allow them to go to new ways or new directions in their research, which they were not anticipating prior to CRISPR-Cas9. Also some scientists who made their career, following up on all the developments of the technologies that have been tremendous the past 10 years, with lots of scientists who became also famous themselves because, they carried on with the development of the technology, allowing the technology to be used even further and more precisely in certain subjects. I never met actually patients who have been cured with CRISPR-Cas9. There is a first patient who was cured, actually the first patient in Germany. And, for the sake of, let's say, the privacy of the person, I did not meet the patient, but I think I have to say the greatest award for me was most likely clearly actually the development of the technology after, 7 years, even less into a cure to treat patients. Because I realized very fast to which extent there were a large number of patients in need. I realize this because you receive requests of patients who are quite desperate and quite ready to try, any types of cure they could try to either for themselves or for specifically kids with genetic disorders. So very alarming requests, and it's here that one realizes the power of the technology. And also the fact that this was, let's say, a primary main application that I was wishing for the technologies, that I had anticipated, that it would be useful to treat human genetic disorders. So I'm personally very happy to see it happening. But again, it's here beyond the fundamental science. This is extremely important. Beyond the fundamental science, there is the development of the technology into applications. And this is also associated to the reason why Alfred Nobel created these prizes is really the applications. And we never thank enough all the people who are developing and have to be very much entrepreneurial to develop further into applications the basic science. And I think this was a message of Alfred Nobel, so we often forget about those who are also doing science and bring the technology forward for good purposes, and I think they should also be thanked. And in the case of CRISPR, it's about clinicians, developers who do a fantastic job.